Welcome, everyone. My name is Wendell Collins. I'm at the College of New Jersey, and I have the pleasure of introducing our next speaker, Sarah Nagy, who is CEO of Seek AI. Sarah will give you some background on Seek AI. I had the pleasure of meeting Sarah many years ago when she was a student at the Princeton's Quantitative Finance program. And I was impressed with her unique background, combination of astrophysics and business economics, which is not something you often see. And I think that's what makes Sarah different in the world of generative AI and AI companies, is her ability to combine business acumen and a deep data science and finance background. She took a different path than many of her fellow Master in Finance graduates in going into data science and technology instead of sales and trading or quantitative asset management, although her career did bring her back around to the quant finance world eventually. After Princeton and UCLA, she led a data science team at Citadel, which is a huge investment firm, and first tinkered with GPT-3. She was impressed by the software's ability to generate computer code from text commands, and she'll give you more background on that. She also worked at Edison and Predata, leading the enterprise data product area at ITG as well. And she has founded Seek AI in 2021. So she's going to give you an overview of what Seek AI does and focus on unlocking the return on investment in on data. Sarah, welcome to TCNJ and the Trenton Computer Festival.
Thanks, Wendell. Cool. So, hey everyone, hope you're enjoying the TCF. It's a pleasure to be here. Yeah, so the title of my talk originally was, unlocking ROI on data. But I felt like, based on, the audience, I decided to talk a little bit more about, it's the computer festival after all. I'm sure this would be a great place for me to actually talk a little bit more about kind of why Seek was founded at a very philosophical level. And even just share my thoughts on computers and AI. And then I'll go into the more corporate side of, why is Seek important to the industry as well, and, the problem that we are solving. So yeah, just to get started, I actually want to talk a little bit about just defining what is an information system. I thought about that a lot when I was putting this talk together. My definition of an information system is a way of collecting, storing, processing, and distributing information. So before computers, we had pen and paper, pencil and paper, we had books. Today we have Google Docs, we have Excel, we have, all the web entities on the internet, texting. To me, these are all information systems that ultimately serve the same purpose of letting our society being able to communicate with each other and store information. So what goes into an information system? You can really boil it down to two components. First, computers, at least in today's information systems. And second, humans. You really need both to create the types of information systems that exist right now. So why is that? Why do you need both of these components to make up an information system? Why do we need computers? These are very basic questions, but I think actually talking about them is very interesting. So yeah, well, computers, okay, what do they bring to the table? Well, they have superhuman computational abilities. Yeah, there are some humans that can multiply large matrices in their heads, but that's like one person. People are usually pretty bad at working with numbers. And then kind of the second thing is the networking ability. Computers enable massive networks for billions of people to exchange information with each other. So these are kind of the two things that I was able to think of in terms of why do we need computers for information systems? These are the things computers can do that humans can't. So what do we bring to the table then? I mean, to be honest, the purpose of information systems in general is to serve humans. So we're the users. We bring the purpose. We tell the information systems what information we want to exchange. We want to see, a friend's TikTok video. We want to check our bank account. Traders want to make trades. These are all goal-driven actions that people take, and that's really what we bring to information systems, all that content and purpose of why it even exists. And just talking a little bit more about, what kind of each piece brings to the table, and also how these things, not communicate, but the type of information that's contained in each thing. So, numbers, if you really think about it, they really are a computer thing. Like they're not a human thing, Something I do find interesting is when you learn computer science, data structures are actually one of the first things that you learn. When you're learning Python, one of the first things you learn is how do I store numbers in a list? That's a type of data structure. And you're thinking about what is even the DNA of computers. It's just the raw transistors that work and store information because of numbers, binary code, ones and zeros. I included this chart of how you can turn these numbers into characters so that humans can interact with computers. But numbers are really the language, so to speak, of computers. And like I said before, humans really just aren't very good at working with raw numbers. On the other hand, words are very much a human thing that only we can really work with. Math, I would argue, is a human thing. Because, if you think about how did math become, how did it originate? It actually began with mathematical philosophy. So it began with language and then became its own type of philosophy, but it's how humans can work with numbers. If you think of it's basic stuff, long division, you need some math to be able to do those kind of computations. But it's more abstract than just the numbers. And so words, math, these are all ways that we think and reason. And also code is kind of maybe not necessarily a hybrid, but a way of, having these things be able to work together. And then, I just was trying to come up with an image. I've used this in a previous deck. It's always a good image to use. And so, kind of thinking about how human-computer interaction, and sort of what I'm defining as quantitative information systems. So if you think about math, right, it's a human thing, but like I said, it does allow us to work with numbers. Again, just think about basic stuff, addition, long division, you do need, math to be able, that's what enabled us to do calculations involving numbers before computers. And so the thing that's really interesting about code, like I said before, code really is a human thing because it's kind of encapsulating math into a language that computers can interpret. And so it's really kind of a magical thing because it's like, it's the bridge between humans and computers. We can actually, translate math into code. The computers understand that code and then can do things with numbers, but at a superhuman scale. So that's really the difference. And before this, we could still work with numbers, but at a very small scale. Now we can work with numbers at a very, very massive superhuman scale. And then I just included some examples here of the benefits of using code to talk to computers about numbers and the benefits that we get out of that. So these are all examples of quantitative information systems. Excel. I also included American Express. I like to go on the Amex website and check my historical transactions. And then just an example of, some Python code. All right, I see a bunch of people leaving, but you know what? I haven't gotten to the ROI stuff yet. So if you guys were here to learn about how you can increase ROI in your company with data, that's coming, but I hope that this is interesting. Talking about qualitative information systems. This is a little bit, it's very, very much different than quantitative. So, things like chat, Slack, text. I included like a Google Doc, the Wall Street Journal. These are all ways of storing unstructured data. And sort of unstructured data is more on the language side, allowing people to communicate with other people through language. But computers still make this, they enable this because of that network component, and the ability to program them and build software. Okay, so for those of you that stuck around, now I'm getting to the good stuff, okay? So why is generative AI such a hot thing? It's really, really very much a gift for qualitative information systems, or at least that's the piece that became obvious first. If you think about, the so-called Turing test, our machine learning team, actually really doesn't like when I talk about the Turing test. They're like, oh, that's not really the best benchmark. Like, there's plenty of other, good benchmarks out there. But I still think, the Turing test is fine. And I think it's incredible. Like, I think it's not talked about enough that AI had passed the Turing test. There's no doubt about it. If you look at like Klarna, I don't know if anybody followed that news, but they replaced, I think, like 700 customer service people with AI. Like you wouldn't be able to do that if AI wasn't passing the Turing test. What kind of AI was it? Like, what is this so-called generative AI? It was probably made obvious by previous talks, but if anyone's still wondering, like, what exactly is it? It is these large language models. Very, very large, systems of matrices with billions of weights connected by nonlinear transformations. Like, that's kind of what's under the hood of these. That's why they're called large. They're very, very large. They have billions of parameters, trillions even. But what's really interesting about them is that they really are next word predictors. I don't know if anybody has followed, like Timnit Gebru, Emily Bender, those type of researchers, but they've always been very vocal about, these aren't conscious machines. Like they've been trained on all of the internet. They generate words one at a time after each other, and in their words, they're stochastic parrots. They're just parroting what they learn on the internet, and it's like a magic trick that works really well. That's kind of their school of thought. And I definitely agree. I mean, that is how these things work. I personally think it's a really, really good magic trick. And, I I think humans are also a really good magic trick. Um, but there's one thing that these things are not, and that is computers. Like as we discussed before, computers work with numbers. Large language models don't work with numbers. They work with language. And like I discussed before, language is very much a human thing. So it's very interesting. Like that to me, like I started Seek, like Wendell said, in 2021. So I've been thinking really, really hard about this stuff for like almost 3 years. And this is something that is very interesting to me after thinking about this for so long. Yeah, actually these large language models, they are closer to humans than they are to computers because they work with language, which is I said this a couple times already, but that's a human thing. And so if we look at kind of the types of information systems that, you know, were written like last year, ChatGPT, I have, a screenshot of that. Just curious, how many have worked with ChatGPT before? So like half the people, that's surprising. Definitely try it out if you haven't worked with it. I think it'll make this all a lot clearer. It's hopefully everyone knows what it is, but if not, it's basically a chatbot that is very similar to talking to a human that knows everything that's on the internet. And then I have another screenshot of a different system, Perplexity, actually a company that shares some of the same investors as Seek. That's also a really good platform that's more focused on search. So it's kind of like a more, AI focused version of Google that is performing very well because a lot of people are using it and paying for it. Yeah, these in my opinion are examples of qualitative information systems, because what you can't do is you can't ask these systems anything about numbers. That's just not what they're good at. There's not a lot of numbers on the internet. But what you can do is you can ask them anything about something qualitative, about language. They're going to be pretty good at it. I'll talk about this later, but I said before, code is kind of like a magical thing because it's kind of bridge between language, math, and numbers. And so I'll talk about that a little bit later, but they can also generate code. And so yeah, kind of got a little bit ahead of myself, but I would say this is one of the key slides in the deck. So like just thinking through, this framework. So math enables humans to work with numbers. Code allows humans to work with computers to do massive work with numbers and build quantitative information systems. Humans can express ideas and goals with language, and humans can reason quantitatively with math. So putting it all together, code generation is a crazy magical thing because it's the key to unlocking quantitative information systems that can work with numbers, and AI is needed to make that work. So that's the belief of Seek AI. Like that's the reason we exist. We're bringing quantitative AI into the world. Question?
Yes, so, okay, we can reason with math, quantitative. We can reason with math, right? But also we can reason with language, right?
Yes, yes.
Right? So, AI is able to reason as it is other than just giving us the information that exists in the internet. You know what I mean?
Yeah, no, that's a really, really good question.
What's the question?
Yeah, so the question was, humans can reason with math and language. Can AI also reason with math and language, or is it just a stochastic pair? That is one of the most highly controversial, I think, topics in AI right now. My personal belief is that, these stochastic parrots are quote unquote smart enough to, that's a loaded term that our machine learning team hates when I use because it's ableist and it's, not really correct in the ML world, but whatever. So yeah, it's quote unquote smart enough to quote unquote reason, enough to pass the Turing test, right? Does that mean it's actually reasoning the same way as a human? Probably not. I mean, it's a totally different system than a human. But it's pretty good at passing the Turing test, both with math to a lesser extent, but definitely with language.
It's okay to say then that unless we figure out a way of making AI understand math, coding is gonna be needed, because it's the way to translate the math into the computer system. Does that make sense?
Well, what's also really interesting is that large language models are very good at generating code. I think they're actually better at code than they are at math. And they don't need math. I mean, like I said, math, I think the way most of us use math today is to be able to communicate with computers, to work with numbers. So, AI, who cares if AI communicates to a computer? Who cares how AI communicates to a computer? Period. If it's writing code and skipping the math step, who cares? And they're actually very, very good at writing code. Anybody hear about Devin this week? Yeah, so Devin, is a so-called AI computer programmer. And it actually, is able to even do tasks on Upwork now, which is like a marketplace for hiring developers. It can actually do those tasks, some of them. So, that's just another data point of, AI is very, very good at writing code. Yeah, and so this is one of the key theses of Seek AI, is that code generation, code in and of itself is already this super magical thing. But then you put AI on top of it, and it's gonna be crazy. And what's really cool is, Seek is actually one of the leading companies in the code generation space. Yeah, I'm really proud of what we've built, and I'll talk about it later on in the presentation. So where Seek is starting is with databases and data analytics. So that's kind of how we started. I'll get into this a little bit later, but like Wendell was saying in my bio, I come from a background as a data scientist and quantitative analyst. So that's part of the reason we focus on databases and data analytics. It's just something I know how to do really, really well, just myself. And so this is kind of the first thing that I focused on with the code generation. It's also a very important thing in our society. Getting humans just access to the data, the quantitative information systems that they need, the data, the analytics. Every company needs this. Even before AI was the hot topic before that was first there was big data and Hadoop, 2012, and then you had machine learning, and there's people were saying we use AI and ML as one phrase in 2017 and 2018. So it's always been this really hot topic. And so most companies need data to operate effectively. Governments need data to operate effectively, and people also need data to operate effectively. How else would you do your taxes? How else would you look at what you've spent on your credit card? So yeah, that's that's kind of where we're starting. And then talking a bit more about how do humans get access to data. There's kind of a couple different, pictures I have here that I can describe in one moment, but really even until basically Seek, like you needed specialized humans to help get you access to data. So we have, very, very small group of specialized humans called data analysts and data scientists, and I myself was one of them. But, most humans like need these specialized humans to help them, get this access to data that is so important. And so if you look at these examples, you do need code generation. I'm showing a Snowflake SQL terminal on the left here to access the data. And the result is, oftentimes you have these dashboards that are displaying the data for you. Earlier in the deck here, I included the COVID dashboard because I feel like this is a really good example of how humans around the world needed data during COVID. This dashboard went so viral. But yeah, just dashboards in general are pretty essential to most companies. So getting into the major problem around working with data. Okay, so dashboards are great. Like you have all the information you've requested from the specialized humans, the data analysts, all in one place, and you can see it every day and it updates and it can even send you notifications. So that's great, but when you really think about what is a dashboard, it's hard coded, right? Like going back, what if you have like one question about this dashboard? How are you going to answer that question if you're not technical and you don't know how to code, which most people aren't? You need to go through a data analyst. So even if you have one question, so what happens if you have 100,000 people in a business that all have questions about this dashboard? That's the major scalability problem. And so yeah, I included this this image here of a business facing person talking to the data analysts or the data analyst. And yeah, I wrote, they're happy, they're smiling, they're laughing, they're collaborating with the data. Like that's really not how I felt when I was a data scientist. To be honest, I was just like, I have a master's degree from Princeton. Like, why am I writing code to query a database to get chicken sandwich market share for you so you can trade Burger King and Chick-fil-A? Like, I was like, I never thought this would be my life. And so yeah, a lot of people that get master's degrees in data science or PhDs enter a very cruel reality when they go into industry and they realize they only exist so that they can do the bidding of the non-technical people. And that sucks. I mean, I hated it. But more importantly, it is extremely not scalable. I mean, like I was saying, you have a company that has 100,000 people and they all have questions, and maybe at best you have a data team of maybe like 1,000 or 2,000 people that are just helping them. And what happens if you have like 200,000 people in the total company and only like 100,000 have access to the dashboard? How do you expand access? You've got to hire 2,000 more people. That's kind of what I'm getting to here. You need to scale the humans specialized humans in a ratio that matches the number of people that aren't technical, that have questions. So that is just extremely expensive. And these are some of the most expensive hires to make too, because they're PhDs, they're masters, they're some of the smartest quantitative people on the job market. So this is the problem that Seek is solving. We're trying to solve this scalability problem. And the way that we're doing it is with quantitative AI. So it's not the same as just the large language models that are already solving these qualitative information systems. This is a way of enabling quantitative information systems with quantitative AI. And so the way that Seek works is we still provide a natural language interface to the non-technical people, and they can ask questions to Seek. But then, Seek will do all of the work of generating the code, and not just that, but crawling through the database, which could have, some of our customers have on the order of tens of thousands of tables in the database, and finding the right data to query, writing the code, executing the code on the data, and returning the results back to the non-technical people. In other words, all the stuff I hated doing as a data scientist. So that's kind of the thing that we're automating, and the way that we're solving this scalability problem. I also included a screenshot of the platform. This is somebody asking a question about S&P 500 web traffic. So Seek, is pulling up the data. We can also visualize the data in the platform, and also provide some narrative, which non-technical people really like, about what's going on in the data. Here it's saying, just kind of describing the results that it's seeing. So I think, from that question, kind of like how good are these systems at, quote unquote, reasoning, or at least how believable is what they're generating. And with quantitative AI, it needs to be right, it needs to be precise, because you have to get the right answers. So that's what makes quantitative AI so much different than qualitative AI. But it is accurate enough to be used in production today by businesses. This is the most widely followed academic benchmark, the screenshot, at measuring large language models or systems of AI models' ability to translate natural language into code. In this case, it's SQL code, SQL, language of databases. Seek actually is the #1 best performing model on this leaderboard. We're the first model ever to break 90% accuracy. We're still the #1 best performing model, even like months later. And if you look at the rest of this leaderboard, you actually see like all the FANG research labs are on there. So yeah, it's definitely something I'm really proud of, is being able to show that we're kind of leading the way in terms of this quantitative AI journey. Yeah, and then just a little bit of information about Seek AI. We've been around for a few years. We were actually around 1 year before ChatGPT. We're working with large language models the whole time. I was working with a model, called Codex back in the day. We were definitely a little bit closer to a wrapper back then, just like building around an existing large language model. But we've since raised, almost $11 million of funding from some of the best, VCs in New York and Silicon Valley. We've been able to scale the team to some quite impressive, members of the ML team. We have people from DeepMind, Stanford, MIT. I myself come from Princeton. And that's kind of how we were able to show the world we were the best at what we do, by being very, very focused on this problem. And yeah, we're actually at a point where we're in production today with dozens of companies. Some of them are, as large as the Fortune 500. Some of them are even nonprofits. And the purpose of us working with them is to help them unlock all that ROI on the data that was previously blocked by the need to hire, humans to do this work that don't even want to do this work. And the reason we exist, at least in terms of our data querying software, is to enable non-technical people to just ask all those questions. and be able to scale that to hundreds of thousands of employees within large businesses. So this is like a little, screen share from our website. Yeah, I encourage you to go on there if you want. You can learn more about us, just seek.ai. And yeah, that kind of wraps up the presentation. We are hiring. We're also, always onboarding new companies. So if your company, if anyone works in this industry or might be interested in learning more about how, your company can use Seek, definitely send me an email. Go ahead.
Question. Okay, I know with large language models, sometimes it's difficult to find out how the computer gets the result it does. But since you're working with structured data, do you at times, let's say when you ask it a question and it gets an answer, you crack open and look at the SQL code and see what it pulls?
Yeah, I mean, absolutely. That kind of, yeah.
And like, do you see that the results or how it gets that conclusion is something as you as a data scientist would find, or is it finding new and novel ways to collect the information and present it?
Yeah, so the question was kind of two pieces. In this interface that I was showing, can you see what's going on under the hood in terms of all the code that's getting generated? Or, the type of data that it chose or any of the other steps in the model. And then kind of the second piece was, well, that was kind of the main question, I think, right?
Yeah.
Yeah, so I think that's a really good question. There's a lot of stuff to talk about there. I think the first piece is, who would actually even care about the underlying code in the first place? It would be those data analysts and data scientists, and they do want observability into what's going on under the hood. So we actually have a completely different interface for the data analysts and the data scientists, where they can see all those steps that the agent took to get to these results. And what's pretty cool is they can even change it to train the agent to kind of learn, how they would have done it. And so each of our customers actually gets their own version of Seek that kind of adapts to their data the more that they use it. We actually, submitted a patent for that workflow in early 2022. So yeah, it's a workflow of, how humans and LLMs can kind of work to train the LLM to query data better for a company. Another thing that is, definitely, again, it just goes towards like how well can these models perform and the accuracy. Part of how we make the system accurate, in addition to just improving the model and having the model itself be really accurate, and also, we can turn on like guardrails too for the data team to be able to basically, like, if they want to block all new questions and, check each one, we try to make it as fast as possible for them to do that checking so that it's still a lot faster than them like manually answering every single question. But another thing we also have is confidence thresholds. So Seek also can kind of know, am I certain enough about this answer to show it right away? Or do I even need to ping someone on the data team for help if it's not confident enough about the answer?
Are you focused on generating people only, or can you also generate source code in other languages?
We started with SQL because, we started when I was just one person, and we're still, fairly small team, but SQL generation in and of itself is a really huge problem. In some ways, it's still, we're still solving it. So yeah, I think SQL generation in and of itself is a really, really hard, problem that the more things we can solve about it, the more value we can add, and it's already a very large total addressable market. But, that's not really our goal. We're not just trying to generate SQL. It's more where we started. We are also expanding into Python, but more for data analysis and data science. And I would say those are the two languages we're the most focused on. But as we grow, we are going to try to pursue this larger challenge of, what other kind of quantitative information systems can we build in addition to data analysis.
You're based out of Silicon Valley or on the East Coast somewhere?
Yeah, our headquarters is in Tribeca, actually, New York. We also have a smaller office in Cupertino. So I myself kind of split my time between New York and SF, and we have those two offices, and also have some team members that are remote.
So if I could continue, with SQL, it sounds like you cover a lot of ground because a lot of manufacturers use ERP systems that are Oracle that can use SQL. So it'd be fantastic for that. When do you how big do you have to be before it makes sense to talk with you? Yesterday I was using a showcase to try to get information out of the system. And I'm not a data analyst. I'm an engineer trying to do 25 other things. But I have to do that to help out and make the company work. You talk to companies like that, or we're Ingersoll Rand, is a bigger solution, or are you going to visit Oracle and make sure their ERP system can do this? And what's the future, and when does it make sense for us to talk?
Yeah, that's a good question. I think it might be helpful to talk a bit about our business model. Yeah, no, we don't just work with very large enterprises. And actually, if we were to work with like an Oracle, for example, we would be more of a partner than, they're not necessarily like our target as a customer. They would be more of a partner to build something, really cool together.
Yeah, I could see them having a tool that they could sell to us to say, hey, you can run your business. Oh, by the way, here's a tool to get the information that you can offer. Right.
Yeah, so that would be an example of a partnership. Like we have a partnership like that with Snowflake, for example. Oracle, I don't know, it's probably coming, not yet. But our customers are, you actually might be a customer, hopefully. So yeah, like, very large Fortune 500, like CPG and beverage companies. Yeah, we've spoken with some manufacturing companies, although that's a little bit earlier for us, that are using those ERP systems. Some of the other companies, types of companies like banks, are a big one that we're kind of starting to work with. We started out more with fintech and actually just B2B software. We're kind of an earlier type of customers, but we're starting to expand more into finance. And then healthcare is another one where we have some of the most experience, actually. There's a lot of data in that industry, but manufacturing, we are starting to work with companies, and
We're probably still, manufacturing in general is probably still small in the US. We'll probably come back because of the China issues. Reshoring. But yeah, usually we're kind of the forgotten child. Businesses in the US.
yeah, I see. Yeah, the China, if you have stuff in China, data there, I could see there being challenges. But we don't just work with, Fortune 500, Fortune 1000. We don't just work with enterprises even. We started out actually with more mid-market companies, like, I think on the order of thousands of people, like low thousands and like $100 billion revenue. We're startups, so like that was a lot faster to work with mid-markets. So we do have like, our own kind of product for mid-markets. And actually we also have even a program for startups, where they don't have a lot of money, but they can be helpful to get feedback from. So we kind of have ways of working with everyone.
For nonprofits, could you elaborate, or can you give an example of how you work with a nonprofit?
Yeah, so there's a nonprofit that we work with in the healthcare industry, actually, that works with hospitals. And they actually have a lot of hospital data. So a lot of operators at these hospitals have questions about like, show me this location and the current ratio of beds to nurses. Those are some examples of questions that they can use to get better visibility into, their hospitals.
You mentioned Snowflake, what are all the databases that you work with?
Well, we started out with cloud data warehouses because we're a cloud-based software. So, pretty much all the major cloud warehouses we work with, Snowflake is kind of our deepest partner, but we also work with Databricks, SQL Server, Amazon Redshift. Those are probably the biggest ones, but there are others as well.
I think there was a question.
Can you explain the difference in what you do versus the patents that are diagnosing disease, let's say predicting cancer from slides? Are you working more on the economic side of the way that the companies work? Or are you working on the diagnostic side of healthcare?
Yeah, so that's a really interesting question. Are we working more with, machine learning that can do things like diagnose cancer? And I think that's a really interesting question because, it kind of makes me want to talk about the difference between data analysis and data science and machine learning. Diagnosing cancer is very much a data science and machine learning problem. Where you need more sophisticated, type of calculations, probably in Python to be able to do that. Seek started out more focused on data analysis. So, we would be able to answer questions that are a lot more repetitive and therefore automatable. Like, that kind of stuff, like detecting cancer, building systems, that's the kind of stuff that data scientists actually want to work on. And because that's a very challenging thing that requires very smart humans to work on. We're more focused, at least right now, on automating the boring stuff that the humans don't want to do. So like basic addition, subtraction, multiplication, division, like those are all things that SQL is really good at. And data scientists with master's degrees don't want to be doing that kind of calculations. They're like, what? Like this is, I remember when I was being asked questions to do analytics, like data analysis, I was like, what? Like, this is like, I learned this in elementary school. So yeah, that's more the stuff that we do today. But it's very, very important, even though it's so basic, it's very, very important for businesses to have analytics. Analytics is definitely more data analysis than data science, but it's so important, but it's also the most automatable. But I would love to see us someday, I mean, how cool would that be to have models that, AI that generates machine learning models, like it's like AI that writes AI, like that stuff really excites me, so, we'll probably have that someday, but yeah, that's what we're doing right now.
You mentioned that some of the LLMs are good at writing code because of their pattern sequences like language. And where do you see like the future of the computing industry with companies like yours and others, whereby programmers and data analysis staff, a lot of them can be automated in one form or another? Like what opportunities do you see as like future worker types that would feed into like this type of platform or similar platforms?
Yeah, I think that's a really interesting question. What happens to the data analysts? And that's kind of essentially your question, right? Yeah, so I think that is something I get asked about a lot. Is Seek gonna just replace all data analysts? Yeah, I don't think we are. Like, at Citadel, for example, my title was technically sector data analyst. So like I was technically a data analyst. I wasn't even a data scientist. But there were so many data analysis calculations that were still really exciting to me. I mean, obviously I was doing a lot of machine learning stuff, it just wasn't my title, but there were still like so many data analysis questions that were really, really exciting to me too. Like in my world, it was like digging through, really massive unconventional data sets and trying to think about how can we make trades on this. But oftentimes that was still using very basic math, but it was still exciting because I had to think about, kind of the trading strategy aspect, and that was cool. So I wouldn't have been worried about being replaced if I was in that job, even though I was doing data analysis work. I would have been like, great, like, I don't have to be like doing these calculations for the fundamental investors that don't know anything about the data. So they're like asking me questions and bugging me in the middle of my research. That's the kind of stuff that that's the reason I started Seek, partially. Like, I didn't want to be doing that work, and I was much more excited about trying to automate it. So if I was in that role, like, I built Seek to be like the kind of thing like I would have actually wanted to buy.
Right, but you also pointed out that like one company replaced the majority of their CSRs with an automated language system. So like maybe it's which areas of the world need up training or different skill training that these type of systems would cancel out because they can be easily automated.
Well, I wouldn't necessarily say my world, with Seek is necessarily, analogous to the Klarna example,
Okay.
because data analysts are still needed in so many ways. And like I mentioned, something that, like when you mentioned a platform, I thought that was a really interesting thing to point out, because Seek actually, we are a platform also for kind of training the model. And so, maybe one thing I can talk about a little bit is knowledge graphs. In the world of data, knowledge graphs are kind of like the hot new thing. Not a lot of companies have them yet, but they're gonna have them. And I think a lot of data analysts are really excited about building knowledge graphs. Because knowledge graphs encapsulate the business logic and the calculations all into one graph. And Seek can actually work with knowledge graphs. So yeah, some of our smartest investors and I have talked about this. Like, current data analysts will also be able to scale their work by just building knowledge graphs. Not necessarily like babysitting an AI, but more building something that the AI can use. So that's why I don't think they're going away. I think they're going to become more like knowledge graph builders. Or just working on more meaningful problems for the business. And then Seek is just going to be there to help them scale all that work to the rest of the business. So I think it's a little bit different in that, like, you don't really have companies that have like large fleets of data analysts. Like if the company I mentioned that has like 100,000 people has 2,000 data analysts. Like, that's for the entire organization. That would be like in the Fortune 10. I think the kind of jobs that'll just be purely automated and people will lose their jobs are, I think customer service representatives are one example. I think that's probably the number one example, actually.
So it's more of a transformation of the data analysis skill set over time.
For sure, yeah. I also think a lot of data analysts are gonna want to maybe become data scientists, and we may just see, the data analyst role shifting into, in this world, there is a new emerging job called analytics engineer. And they are the ones that often build these knowledge graphs. So I think data analysts will either do more analytics engineering, or they'll do more data science work. But what they're not gonna be doing is like being there just answering questions all day.
Any last question?
I'll try, can I get through both or?
Sure. I just didn't want to, go ahead.
I'm gonna be really quick. So within the next 5 to 10 years, I mean, the data science is becoming a very big thing right now, as well as prompt engineers and all that. In the 5 to 10 years, do you think data science will continue to grow?
Yeah, I think data science is gonna continue to grow because I think it's also really helpful to think about a world before ChatGPT. Like, what was important to businesses when AI wasn't like the hot shiny thing. And, you know, data was like the hot thing before AI, and data science is so needed in, you know, that I kind of had a slide about that, like, you know, somebody's gotta build the COVID dashboards. Well, I mean, Seek is probably gonna do that, but like, somebody's gotta, you know, somebody's gotta build the cancer detection, you know? That's the kind of thing that I think, that's not gonna get replaced anytime soon. Building ML that can detect cancer, that's not gonna get replaced anytime in the next, you know, couple of years, I would say.
Last question.
Oh, I think that was me. So it sounds like you don't have like a public interface, right? Like some of the other LLMs, you have like a public website or whatever.
Yeah, we don't yet have a consumer, like an individual facing app that you just go on and try it. We thought about it, but it didn't necessarily make a lot of business sense to us, because when you think of like, who are the individuals that would wanna use it? It's broke college students, it's data analysts that are bored and are just gonna leave their jobs, like, not a very lucrative, you know, market for us, unfortunately. But I do think we're gonna start doing some of that stuff to get the word out, and it is great marketing. I think, something we're currently thinking about is what data sets are we gonna start with, you know, build something like that? You know, doing something like that with the world's economic data is something that we're actually starting to think about, so, that's probably coming. But yeah, as of now, you know, we are B2B, so you basically need to email me or request a demo on the website, or email one of our sales reps to get a demo.
The education market would be an interesting one, to be able to teach future data scientists from tutor.
Yeah, actually, we do have partnerships with universities. I didn't mention that, but NYU, we're starting to work with the University of Kansas. There's a university in Germany, University of Tübingen. So we do have these kind of partnerships with courses that, you know, we're starting to work with, yeah.
I was also curious what primary language is your product written in? Like Python?
Yeah, we're actually mostly written in Python, yeah.
All right.
All right, thanks. We're hiring.
Very good.